Hi there everyone, today's video is so cool I decided I had to wear my sunglasses. And the object we're going to show you at the end, which is in this box, was contributed by one of you, the Objectivity viewers. How exciting is that? Keith, where do we start telling this story?
Well, we start with these government reports. So these are, as you can see, reports of the Departmental Committee on Compensation for Industrial Diseases. This is from 1907. The government was looking at who they should compensate by paying money to for people suffering from industrial injury. And the cataracts that glass workers were getting was added to the list.
Presumably that's because of all the glowing glass and the light and
That's
the
right.
high frequency light.
It was having an impact on the eyes. Obviously they didn't know what the impact was at that time. So the government asked the Royal Society to look into the problem. Obviously the government never wants to pay money to people. So the Royal Society's role was to try and find out about this, and probably the government thought it wasn't going to have to pay out any money for it, but tough.
Okay, what's this then?
So this is a report on cataract in glass workers with an appendix. This is something commissioned by the government in 1907. They weren't quite satisfied with that, so the Royal Society decided it would investigate on behalf of the government.
I've just realised I'm still wearing these glasses. I'm going to lift them up. That's kind of weird.
So here we have, this is 1908, and in this bundle of papers you can see this is a departmental secretary writing to President of the Royal Society, it's Lord Rayleigh. I have the honour by direction of the Secretary of State to say that the Departmental Committee, which was appointed in 1906, blah blah blah, it's really asking the Royal Society to help. It leads to the conclusion that a form of cataract commencing in the posterior cortical region of the lens is almost peculiar to persons exposed to the glare and heat from glass furnace. They're still thinking it's possibly heat at this stage. The Secretary of State would appreciate greatly any assistance which the Royal Society could give in the matter, and he ventures to ask you as President of the Royal Society whether elucidation of the physical and physiological problems involved could properly be made the subject of an inquiry by a committee of the Royal Society.
It's kind of like a scientific bat signal. Come on, Royal Society, come to the rescue.
That's right. Well, I like to think that bat signal would have the Royal Society coat of arms projected into the sky.
We so need to get one of those made.
Yeah, that could be the next object.
Okay.
Yeah, okay.
All right. So what does the Royal Society do?
The Royal Society forms a committee. That's what the Royal Society always does.
They like a good committee.
We like a good committee, yes. Yeah. And we have the committee minute book here. Now, this is something that lots of fellows served on. This is the original committee, but you can see one person who's very important here for our story, which is Sir William Crookes. And you may remember, if you cast your mind back, I think the very first Objectivity video might have been about Crookes and his radiometers.
Oh, yeah, that's the good old days.
That was when we were young and handsome.
All right, so Crookes is on this special committee that the Royal Society forms.
Yeah, and he conducts researches, and it's formed from 1908 onwards, and it actually goes right through to the 1920s. It's quite a long serving committee, this one. So we have one of the reports here, and you can see that at this stage they're doing experiments at Messrs Nuttall and Company's glassworks in St Helens. So they're using factory floors in order to conduct experiments. And you can see here, when we were there, light green bottle glass was being made, and it gives you the mixture and what happens to it. The area of the tank of molten glass is about 82 square yards, and it contains from 300 to 350 tons of the mixture, technically called metal.
So they're going out to the coalface and measuring stuff and finding out what's going on. Okay.
So Crookes eventually looks at infrared radiation, ultraviolet radiation, what is causing the problem. They do ultimately find it's ultraviolet predominantly. However, Crookes begins to think about not just doing something, but experimenting on lens solutions. So what kind of glass might be protective for glass workers while they're going about their jobs. Crookes initially thinks about marketing lenses, making some money out of it. It doesn't happen. The First World War intrudes, and of course glasswork is very important during the First World War. But afterwards, in the 1920s, he does begin to market lenses in collaboration with manufacturers and opticians.
So for industry, basically?
Yeah, but also it begins to spin out into other uses as well, because as you can see...
Starting to make sense now, isn't it?
Lots of people are interested in anti-glare lenses. lenses and not just for industrial purposes. But the work of the committee continues, and we have some of the reports of the committee here.
Right.
This is post-World War I, and what I find interesting about these is that they begin to employ women to look at the question and to produce reports for the committee. Now, of course, this is very early for women scientists, and you can see here we have one of the reports commissioned by the committee, and what they're looking at now is what changes in the lens. So this is observations on the crystalline lens, and it's by Claire Harris. Now, it's not very often in these days that you find a woman writing things for the Royal Society. Equal opportunities are just beginning to kick in, and the Royal Society is responding. So it says this research, having for its final object the explanation of conditions which prevent or determine the occurrence of cataractous processes in the crystalline lens, was undertaken with a view to studying some of the fundamental physiochemical relations existing between the lens itself and the fluids which hold it.
Tell us about the box that I promised we'd talk about.
Well, one of the nice things about Objectivity is that viewers occasionally come and visit the Royal Society, which is great, and every now and again they bring things in with them, and an Objectivity viewer rather nicely brought in some Crookes anti-glare lenses.
What is one of our viewers doing with Crookes anti-glare lenses?
You can get this sort of thing on eBay.
Bought it on eBay.
Yeah.
Bought it on eBay, sent it to Keith.
Yeah. These things were made from the 1920s, right through to the 1960s, I believe. So these ones were manufactured by the William Crookes Anti-Glare Company.
Look at this.
Yeah.
So William Crookes U Ultimate Anti-Glare Formula. That's some good marketing. He's like...
Yeah, that's absolutely right. So Crookes does very well out of it, and as we can see from your eyewear, Brady, the rest of us did very well out of it as well.
The tradition continues. I always think of these old-fashioned scientists who I see portraits of, with their beards and their suits, as really kind of altruistic and a bit stuffy and boring. But it sounds like Crookes, he didn't mind a bit of marketing and making a few bucks on the side.
Yeah, many scientists at this period weren't averse to a bit of capitalisation and going into companies and producing things that were useful for people.
So what will happen to these lenses that our anonymous but very kind viewer has sent in? Are these going to get a proper Royal Society catalogue number and go into?
Added to the collections, and you never know, might be exhibited in a future exhibition at the Royal Society. So look in your attics.
Amazing.
And on eBay.
I'm guessing this is our object. Tell us, we're talking about a guy called William Crookes.
Well, that's right. William Crookes eventually became a president of the Royal Society, very eminent chemist and physicist. And he invented a raft of instruments, many of which turned out to be very, very useful, some not very useful.
Not very useful. That's my favourite guy.
Indeed.